Hello everyone and welcome to another session of object-oriented programming using C++. And in this session we'll discuss about templates. And first we'll discuss what is template. Now templates in C++ language construct that support generic programming. Now let me tell you what is the meaning of generic programming. Here when it says generic programming, since I mean to say that it is generic in the sense of data type, okay, saying that it will try to provide a programming which will be type independent, a programming constructs that is type independent. Now what is a template, especially in C++? Let me tell you about mostly what we do in C++. Till now we have seen that we have done generally defined functions, okay, it's modular programming is a part of modular programming. We define functions or we define class, okay, class with members and member functions, okay. Now when I say a generic class, now let us come to two things. So can be possible that a generic function or could be a generic class. What is generic class? How shall I decide that whether this class is a generic, can be a generic class? Okay, so generic class mean a class which behave in the same way independent of the type of the data members. Okay, remember this line, that a class that behave, which has a behavior or which have attributes which really doesn't change with the type, means those are type independent. Okay, so it doesn't matter whether the type of the member data member, type of the arguments of the member function or type of the data members, okay, which if they are changed, then the actual task which has been performed by the class or actual behavior of the tasks of the functions or the members doesn't change. The nature doesn't change. There, I mean to say that if let's say color, we are representing color. So if let's say instead of integer we represent the color in terms of a character, it doesn't change the meaning of the color. So those kind of class where if you they will do the same task independent of the data type of the data members or the arguments of the member function. In that case I can say yes, this could be a generic class. This class can be a generic class because there can be a copy of this class which may have data members may have integer, can be a copy of this class which may have data member as a double, and so on. Okay, so that here mean by generic programming, and the same definition is applied to the functions also. Now suppose we have a function whose task doesn't change with the data type. Okay, means if the input, let's say it takes some arguments, okay, if those arguments are integer, it does the same task, okay, and that this task doesn't change if the arguments change to double. If the arguments are integer, it performs some task, and the arguments are double or let's say float, if the task changes, then we cannot say that is a generic function. Okay, so for those cases this task remain the same, then we say this is a generic function. We'll see some examples. Like for example, I'll say that swapping of two variables. So doesn't matter whether the type of the variable is integer or the type of variable is double or type of the variable is a character. So swapping functions task remain the same, only to swap the values, doesn't matter what is the values type is. So swap function can be a generic function. So to write those kind of function we can use templates. So templates can be used to create a family of classes or a function. Okay, so instead of creating them explicitly using the raw programming way, we can take the help of template to create a family of classes or function. The templates may also be considered similar to macros. Why? So how it is defined in C++ is that when an object is defined, say for example we have a template class. So whenever we create an object and define a specific type or type, let's say yes, this object is of type integer, then the template definition for the class is substituted with that required data type. Meant to say that we have a generic class where a type has not yet been decided. So when we create an object, let's say that can be of any type. When you create an object of defining type integer, so wherever the type is required, that so we can say a copy of the template is created with type replaced with or type substituted with integer. Suppose we create an object with type double, let's say, which is a type is double, then all the places where the type is mentioned, that will be substituted. So a copy of the class or all the class members are created for a particular object, for a specific object based on its data type. That's why, because it is substituted during the compilation time to create its copy, so it is considered similar to macro. Next, it allows the compiler to generate multiple versions of a function by allowing the parameterized data type. Okay, so based on that, now a generic template is created. Now depend upon how many what type of data type is used, for this generic template, a multiple copies, multiple versions of the function is created. So there is a generic function, depend upon if you need this function with the type integer, one copy is created. We need one version with double, another version is created. In this way, from the template, multiple copies can be created. That's why multiple versions of, that is the main idea how regarding defining a template in the for a template for a class or for a function. Okay, so in C++, templates can be either a function template or a class template. So function template defines the logic behind the algorithm that work for multiple data types. So a function defines some logic, defines some task or algorithm. Okay, so here it remains same for multiple data type. Then class template, this define the generic class pattern to which a specific data type can be plugged in to produce a new classes. So class is a generic class where data type is not fixed, and depending upon the any data type, okay, we can plug in or we can put the data type and create the corresponding version, let's say integer version of the generic class, the character version of the template class, so and so we can create the pattern from the specific type from the generic class pattern. So let us discuss the function template, how we can define a functional template. Let us first understand the need. Okay, we have seen so far. So need is that, let's say we have to swap, right? So we know so far that to swap to integer, we have to write a function with two input of integer type. Now suppose I have to swap two doubles, then definitely I cannot use this function. I have to define a separate swap function where the arguments are double. Okay, now I have defined double, but next I found that I have to swap two complex numbers and I have a complex class, but in that case I cannot use this swap function which is meant for integer. Also I cannot use this swap function which is meant for double. So I have to again make a separate. So I will take a copy of this, I will copy and paste it, and maybe I'll modify this. This is the general way to do it. So this is you can consider as an overhead. Like every time you need a separate copy. You need to create a separate copy. You have to put within your program a copy for each data type. Same swap function, same behavior. So in this case, we found that doesn't matter whether it is integer or swapping, does the same thing. So here we can define a function template. Okay. So we observe that the function logic remains the same, because for the swap, it has to swap two values. Doesn't matter what is the values, only they differ by data type. So we can define a function template that could be used for any data type. So task remains the same. So we can define a template which can be used for any data type whenever required. So in this way, we can define a function template. So to define a function template, this keyword template along with class T marked within less than and greater than symbol should be present before the function, before the generic function or template function. Okay, so we write template class T indicate that we are defining a function template. So then we define the function. It is normal way, but wherever the type, okay, here, so we are defining the type T. Class T means the type T. Okay, so whenever we mention a type, okay, argument a type, we mention the value T. Okay, so use type T wherever required in the function. So wherever we know that will be of any type. Type can be anything. So there we mention type, because this will be decided by when the function is actually created. So but we are generating a generic function. That's why in the template we mention the type T. So let's see an example. So for swap we write template less than symbol class T greater than symbol to indicate that this is a template function template. Okay, we define the function, but we see that whichever part is generic, okay, all the place we mention the type T, because we are not defining the fixing the type here, because it's a generic function or it's a template. So class T is defined, so wherever that the type is generic, we mention T ampersand x, T ampersand y, T temp equal to x. So the logic remains the same. Only thing is that it will work for any data type. That's why this T is just like a variable which can be replaced by any valid data type. Alright. So this function, now how to use them? The question is how to use them. Now int a20 b10 and I call the swap function a comma b. So whenever there is a function call like this, indicate that I am calling the swap for the integer type a and b. So a compiler during the compilation will see this and create a integer version of this by, so it means it is going to replace T by integer for this function to invoke this function. Now m float m 9.8 and 6.7. So here the type is float. So when the compiler encounter this call, it create a floating point version of the swap, and whenever it see a complex, okay, swap C1 C2, it will create a complex version. But you know that we have to do some additional task for that, because we cannot write directly. Can we write it directly? Yes, we can write it directly. Assignment operator can be done, but if any other operation is involved, you have to overload. You remember that. Okay, so when we say complex and C1 C2, so we are going to, the corresponding swap function for the complex will be generated. Alright, so you see that we do not have to write the multiple versions of swap for each data type. So we don't have to write a swap function for integer, we don't have to write a swap function for floating point or complex number or any other further type. So you have seen three classes, three type here. In future it may happen that we may also use for other data types. So that is also been taken care by this template. So that is the benefit. So we don't have to define additional functions. It is multiple versions. So the compiler is going to take care. Actually, the compiler is going to create it, but it is user task is reduced. User can define a simple template, and the task will be done. Now another example, the sorting. Okay, the bubble sort. Now again same thing. For an array, doesn't matter what the type of element present here, the bubble sort is going to perform sorting. Okay, provided the valid data type is provided. So for a valid data type, bubble sort will always do bubble sort. Doesn't matter if it is integer, it will do bubble sort. It's a floating point, it's going to do bubble sort. So we can define, so suppose we need multiple version, we may have to sort an floating point array or an integer array. Okay, maybe we have to sort the characters. So in that case we can define a function template for bubble sort. So template, so class, because we are using swap function here, so we are bringing the swap function which already been defined previous example right here, and here bubble function as bubble sort function. Okay, it is performing bubble sort, class T, and the type is T here, so it doesn't matter what type of array we provide here, it is going to perform the bubble sort, and we can call accordingly as just like here. So we have an integer array here and a floating point array, so we are calling first time bubble for the integer array to sort out the integer array and then sorting the floating point array. Alright, so another example, the use of template function template. Now sometime function template may have multiple parameters. Till now we have seen the examples where the arguments are of same type. We have seen multiple argument here for the swap where the type is same, but sometime what may happen, the generic type we define may have different type, but still they will do some task. I'll show an example, may not be a perfect example for this, but just to show that how multiple generic template parameters can be used here. So When we have multiple parameter, we previously defining only one parameter t, now we define template class t comma class u. So we have multiple parameters here. That means we can define through multiple parameter, not only always the same. So here max return type here, so you show that return type is always u. We show that here return type is u. Among the t and u, then u, whatever the u type will be, that will be the return type of the function. So that means what is what? Actually, we can observe that it is actually the compiler is going to create a specific version of this template function template. Okay, it is never going to be generic like this. When they compiled, actual a specific version depend upon the type passed or type of the argument passed, a copy of this template, a specific copy of this template is created. So that is the benefit. The compiler is taking care of all this. So first argument is of type t, second is u. So then if x is greater than y, return x or else return y. So logic is very simple here. So let's see, for x we are defining a variable integer x with 10, a character c stored in y, okay, and we are comparing between, so it is a valid. So make sure that you do a valid, you pass the valid data type. So you are, if you are not defined the logic, that the function template cannot handle the cases which are not been defined within the functions. Okay, so we sure it can handle the cases comparison between an integer and a character, an integer and a double. So we are calling here for x and y. So that means first type will be an integer type, second type is a character type. Okay, so here return type will be character. Okay, here it is will always be return type will be, so the corresponding character value will be returned. Similarly here, so x z integer double, return type will be double. Okay, first parameter is integer, second parameter double type. So in this way we can pass multiple parameter to a function template. So depend upon how many different type of generic data type are involved within the function. Coming to class template, class templates allows to define a class with data types as parameter and use it later to create a class of any specific type. So we can say it's a generic class. Similar to the function template, the class template will be initiated with the keyword template and a class type t. Okay, and wherever the generic type is data type is involved, we replace that the type as t. Instead of writing a specific type, we write t. All right. And here is a vector example, and we can create a vector class with integer vector, floating vector, okay, any type of vector. So we write like this. So let us see, we have seen the vector class, but we revise it using the template. So template class t, and we see that previously we were defining, suppose for integer vector we are defining integer vector, now we are defining t star. So indicating that it's here the type is substitute, can be generic type, maybe a set of character vector, can be integer vector, can be double vector, can be floating point vector. So and so here it makes it, so this t makes it a generic class. Okay, this type is defined whenever an object is instantiated, okay, or object is created. All right, int size then remains. So here is a parameterized constructor to create a vector, and we have another parameterized constructor to create a vector. Okay, so it is a single parameter, double parameter. Then we have a function sum to find the sum of the element of the all the element present in the vector. Okay, so a small class defined for this, and we see that how so this is generic class, how we instantiate a copy of this class. So when we create an object, we have to pass the type of the object to be created. So that type, now this type will replace the value of t. So first line, vector int, okay, int should be placed within the less than and greater than symbol. That indicates that an object v0 is created, okay, with type integer. Okay, so what will happen for this object, a copy of this class is created with substituting t by integer. So integer vector class. Okay, so for that, so that v0 object is created for integer value. All right, then we again we create another object with again integer type. Okay, so no, fine. Then we are creating a floating point array to create a vector. So here a vector, another vector object, but type is floating point array. So when this is encountered, compiler is going to substitute t by the floating point type to create a floating point version of this class. Okay, and so on. So depend upon what type of vector we create, what type of object of vector we create, corresponding version of the class will be generated from this generic class. Now the template class can take default arguments. Okay, now a template class can have default arguments, just like we mentioned default argument in the function. If you remember the discussion of function in the class, okay, we can provide default arguments where when no argument is passed, value is passed, so it will take the default value. Similarly here, so we can assign default type here. So it takes the argument as type, so the other functions will take value. Now it will take the argument as type. You can see, you have already seen that first argument is type integer, second integer, third is float. So when this type is not provided, suppose an object is created without providing this type, so what should be the default type of this class? Okay, so that can be provided by again similar to the function default argument, template class x equal to the type, default type. Here it is integer, so int. So class x equal to int indicate that whenever the type is not mentioned, so okay, by default the integer version of the class is generated. So default value is used when no explicit value is specified, when the class object is instantiated. When the object is created and the type is not mentioned, default is going to be taken. So default arguments for non-type parameters are specified using the same syntax as default argument for the function parameter. Now for non-type parameters, so the parameters in the member functions which take some value, their default arguments are provided exactly same way as we discussed in the function parameters. Here's the example, the example we modified. Now template class t equal to int indicate that whenever an object is instantiated without any type, then by default it should create the integer version of the class. So here you see that we instantiate object with integer here, but here you see that vector v1. So here no type is provided, so for this object the integer already must have created, so integer version of this class is created. So type is t is replaced with int for all the t present in the class. Okay, so this is default type. Okay, by providing default type to the class template. Okay, so this answer discussion of template. I suggest the reader to go with more examples from the book to understand it more clearly.